type of angle ACD is. What do I call that? ACD is what type of angle? 7. Central angle. Good job, because it comes from the center. All right, my next question is angle ACD. How do you find it? ACD, how do I find it? 15, how do I find that angle? What's the name of the arc? Okay. All right, everyone's good. That's how I find a central angle. I'm asking you guys this because I'm going to show you a new type of angle today that's not central. All right. What I'd like you to do first, now you can write on your notes, put a point somewhere on your circle. Put a point somewhere on your circle, please. From that point, draw 2 chords. From that point on your circle, anywhere, just draw 2 chords in the circle from that point. So you should have 2 chords coming from that point. We good there, Carter? Can we get going? Am I interrupting high score again? All right. So I don't care where you put them. Label all 3. Actually, you know what? Why don't we have all the same labels here? A, B, C. We'll go traditional. If your vertex is on the circle, it is now referred to as an inscribed angle. All right. Central angle was when it was the center. Inscribed now, the vertex is the center, and that's not good enough, by the way. That's not good enough. Vertex is on the circle, and the other 2 sides are what? What did you draw in? They have to be chords. Okay, they have to be chords, the other 2. Now look, if I do this, get rid of that, that. There we go. Is that inscribed? No, I know it's on the circle, but that's not a chord. It's got to be a chord. Let me do this to you. What do you think about this? Is that angle inscribed? Why? Those are 2 chords. What's the problem? Thank you. The point is not on the circle. So everyone see what's required. All right, so let me go back to my diagram. How do I find the measure now? Okay, how do I find the measure of angle ABC? Here you go. Inscribed angle. Here's your one of 3 theorems today. Inscribed angle. Remember, a central was equal to its arc. Inscribed, half its arc. All right? Inscribed angle is equal to half its arc measure. Half now. I take half. So go back up to your angle here. Angle ABC. We're going to take half of which arc now? Arc AC. That's how we're going to find the inscribed angles. We're going to take half its arc measure. All right? Questions on an inscribed versus a central? All right, let's go. Boom. Help me out here. Do you see 3 inscribed angles in this diagram? Do you see the 3 inscribed angles, A, B, and C? Good. All right, first thing I'm asking for is, what's the measure of arc BC? Does BC go through the center? No, so it's not a diameter, so don't tell me it's 180. All right, it's not going through the center. How can I find arc BC? Well, let's take a look. What type of angle is angle A up here? 11. What type of angle is angle A? Do we have an 11?
Oh, yeah, inscribed.
Inscribed, right? It's inscribed. And we take half whatever its arc was. So if the angle's 80, I don't want to take half of 80, right? What do I want to do instead to find the arc? It's go in reverse and take 80, multiply it by 2. Because I need to find a number I can take half of and get 80. And that number, 160. So I'll label my arc ABC 160. All right, angle B now. What's the measure of angle B? All right, same question. 3, what type of angle is angle B? No, not, I just, what type? We'll get to that in a second. It's inscribed. So I'm going to take half. What arc is it drawn to now, Stella? Which is what's the measure? Sorry, 88. There you go. Everyone's seeing how inscribed works now. So that's 44 degrees. All right. Part C is angle C. And guys, I'm not going to force you to do a circle theorem every time. If you can find angle C without using a circle theorem, that's fine too. Everyone see how you don't need to know anything about circles to find angle C another way? Yeah. I know angle C is inscribed, and maybe you would take half of arc AB, but do I need to? No. How can you find angle C here? Look what I gave you in the diagram. 1, George?
80 plus 44, and then 180 minus 1.
It's the third angle where I know the other two in a triangle. So I can do 180 minus 80 minus 44. What's that one end up being? I should probably get my own. 56? 56? All right, so that's 56. And then my last question, all right, what's arc AB? A couple different ways you could do it. Okay, how are you going to find that measure now? You let me know how you did it, because there's a few ways. 10? Josh?
Multiply by 56 by 2.
Yep, multiply 56 by 2. Anybody show of hands here, how many did it a different way? Zach, how'd you do it?
360 minus 88.
360 degrees in a circle minus the other two arcs. Good work, both of you guys. Good work. 112. All right. All good? Questions? I'll let you guys go ahead. Example 2, I'll walk around here. Find both angle ADB and ACB for me now. Now you know about inscribed angles, and we'll talk about something interesting that happens here. All right. What'd you find for? Let's start with angle ADB. ADB. What'd you find? 6.
62.
62. Yep. How about angle ACB? What did we find? 19.
62.
All right. They both came out to be 62 degrees. Yeah. Why? What did you do in this problem? You took half an arc, didn't you? Which arc did you take half of both times? The same one. And they ended up being congruent. You just found out theorem number 2 now, today. You took, ready, 2. What type of angles are they? Inscribed angles. 2 inscribed angles drawn to where? Where were these 2 equal angles drawn to? Same arc. 2 inscribed angles drawn to the same arc. And what'd you find out about them? Are congruent. All right? Every time, everyone. Every time. 2 inscribed angles drawn to the same arc, always congruent. I'll get you started on number 3, and then I'll let you go and finish it. Everyone look at ABD for me, angle ABD. What type of angle is ABD? 19 again. ABD. What type of arc? What type of angle? Excuse me. ABD. 19. Inscribed. Yeah, we're good. It's inscribed. What type of angle is ACD? 7. Type of angle is ACD. Inscribed. They're both drawn. Everyone see? Both those arcs are both those angles are drawn to which arc? 7 again. Same arc. 2 inscribed angles drawn on the same arc are equal. Go right ahead. Just make sure though you find arc AD at the end. I don't care what the angles are. I want to find arc AD at the end. Go ahead. So we got out x equals 5 when I set them equal. I plugged it back in and got 56, but that's only the inscribed. I need the arc though. All right, so if I know the inscribed here is 56, what can I do with that info to get the measure of arc AD now? 16, what can I do with that 56? Okay, no problem. Let's try that one more time. 10, Josh. There you go. So we should have ended up with 2, carry the 1, 112. So if you see 2 inscribed angles and they both go to the same arc, automatically they're equal. Whew, questions? Sorry to throw a lot at you today. This is the last stuff before the quiz, though. All right, next up. Ooh. All right, help me find x, angle y, and then arc AC, the measure of arc AC. Everyone see the diameter I got floating there, EB? All right, can we start with x? Nine. What type of angle is x first?
Inscribed.
Thank you. Don't steal the fire, please. It's inscribed. Everyone agrees it's inscribed. So the rule is to find it, you take half of its arc. What arc is x drawn to? Help me out. 17. What arc is x drawn to?
Arc AB.
All right, everybody. Arc AB. We have talked about these before. What's that called right there? That arc that I just highlighted. It's got a special name. 4. Remember it all? Okay. Diameter, half a circle. Semi-circle. Semicircles measure how much? 18?
180.
180. So I'm going to take half of 180. Everyone's all right where the 180 is coming from. That's drawn to a half a circle. So yes, angle X is a 90-degree angle. Everyone stop there. Don't find Y for me yet because I want to introduce our third theorem here. It says it right here, but I'd like to rewrite it so we can understand it here. Inscribed angle drawn to, where was this one drawn to? Where was this inscribed angle drawn to? Hey, what?
Diameter.
Okay, I like the word diameter. Anybody else want to use a different one? semicircle. Either one's fine with me. You want to write an inscribed angle drawn to a diameter, drawn to a semicircle, that's fine. Drawn to, I'll use diameter here, but if you want to use semicircle, keep using it. Inscribed angle drawn to the diameter is a, I don't want to write 90-degree angle. Right angle. There you go. So if you see an inscribed drawn to a semi or a diameter, it's automatically a right. You don't even need to show me all the work up here. Automatically a right angle. All right, let's find y for me. Can you help me find y? Who's up here? Josh, I don't even want to do any circle facts, Josh. Can you get me right to y?
Yeah.
Yep.
It's 180 minus 58 minus 90.
Yep.
32.
So that's 32. And the last thing it's going to ask me for, can you guys help me with the measure of arc BC? What's the measure of arc BC for me? How can I find that measure, BC? 16. Yep. 16, 11.
32 times 2.
Double the inscribed angle, 32. Good. Great job. Inscribed angle drawn to a diameter, got to be a right angle. And the final fact before the quiz too, you guys have some room in here. Can you draw a circle underneath this theorem for me? Draw me a circle. Here's your job for me. And put the center in, sure, yeah, put the center in there. Can you make a quadrilateral inside that circle, but all 4 vertices have to touch the circle? Okay, so inscribe it. Make a quadrilateral where all 4 vertices touch the circle. I don't care, rectangle, rhombus, square, trapezoid, kite, nothing, 4 sides. That's what I want. That touch the circle. Make mine a little crazy here. And label it A, B, C, D for me. Go clockwise, counterclockwise, doesn't matter. And here's your last fact. If you have this diagram, the quadrilateral inside the circle, opposite angles are supplementary. They add to what then? Okay, so in our case, angle A plus angle C equals 180. And the same thing can be said for B plus D. Also equal to 180 degrees. Quadrilateral inside a circle, opposite angles supplementary. With that being said, try out that last problem on your own here. It's kind of a combination of everything we talked about today. Find the arc and then find angle F. Okay, we're finishing up here, huh? How do we get GFE? How do you get a arc GFE? 3, how do I get arc GFE here? What's that? Why half of 360? So this is you're saying this one's 180. Where's the diameter? Right? No diameter here. Look at the 86 here, so look at the 86.
Oh.
Doesn't it go to, where's it go to? This arc here, right? So what should I be doing with the 86 if it's inscribed and I need to find the arc? by 2. Yep, double it, and we end up with 172 degrees. Everyone see that? We're good. And how do you find angle F? Know my theorem. That's how you find it, right? 8. How do I find angle F?
Supplementary to 80 degrees.
Opposite angles in a quadrilateral. Supplementary. 180 minus 86. What do we end up with? 90. 94. Tomorrow we get reviewing. Hardcore. Please start the homework and nothing else. Oh, hold on. Time out. I know one of the problems coming up in your homework, and I just want to make sure you're prepared because I don't want you to skip over it. It's going to ask you to do a proof, and the proof is going to say prove these two triangles similar. You guys remember the main method of proving triangles similar in a proof? Oh boy. Come on. 2.5 months we'll be sitting down for a Regents. What's the main method of proving two triangles similar when we're doing a proof? Angle. Angle. Done. That's it. You just have to find two congruent angles and they're similar. All right, because that's going to be coming up in your homework here in a couple minutes. So angle, proving two triangles similar. Got to prove two congruent angles.